Hi everyone, this is Dr. E. Sridevi, Professor, Department of Electronics and Communication Engineering. In this video lecture, we are going to learn about electric field intensity. On completion of this course, this module, the learners can able to understand what is the concept behind electric field intensity and the applications of this field intensity. So first, the definition of electric field intensity. It is represented by the letter E, that is capital E. It is defined as the force per unit positive charge when placed in an electric field. So force is denoted as F, charge is denoted as Q. Force per unit charge means F by Q. So mathematically, the electric field intensity E is given as capital E is equal to F divided by Q, and the ratio F by Q is called as electric field intensity. It is a vector quantity measured in networks per coulombs. N bar C, newtons per coulomb. N is called as Newton and C is called as coulomb. So N per C is called as newtons per coulomb. It is the unit of E. Otherwise, it is noted as volts per meter V by M. And electric field intensity, the definition of electric field intensity is that is a point is a force experienced by a unit positive test charge. So electric field intensity at a point capital E is represented by the force experienced by a unit positive test charge placed on it on that same point, that is E is equal to F divided by Q. So unit is N by C, newtons per coulomb or volt per meter. So the electric field due to point charge Q is given by E is equal to 1 divided by 4 pi epsilon naught into Q divided by R square into R vector. R cap is nothing but unit vector. So the direction. While talking about the direction, it is away from the charge if Q is positive, and it is towards the charge if Q is negative. So these all are the basis about electric field of a point charge. So electric field in vector form is represented as E is equal to K into Q divided by R square into R cap. R cap is the unit vector, where K is the constant which is called as or which is given by the numeric 9 into 10 power 9. R cap is the unit vector from from that particular charge to the point. Electric field in a medium. If the charge is placed in a medium of permittivity epsilon, then it is noted as E is equal to epsilon naught into epsilon R. Otherwise, it is written as E is equal to 1 by 4 pi epsilon into Q divided by R square. That can be written as 1 by epsilon R into epsilon vacuum. So that is electric field in a medium. So after knowing the basis, next is the superposition principle of multiple charges. Let first charge is Q1, second charge is Q1, etc. up to multiple number of or several charges. Let us just imagine let us having several charges. So the network or net electric field intensity E net is calculated as E net is equal to E1 vector plus E2 vector plus etc. up to the last charge. Each field is evaluated independently and then added vectorically. So electric field due to a point charge is defined as E is equal to, as we said earlier, E is equal to 1 by 4 pi epsilon naught into Q divided by R square, that is force per unit positive test charge. So where E is the electric field intensity, which is denoted by the unit Newton per coulombs or volt per meter. Q is the source charge C, and R is the distance from the charge in meters, and Q is nothing but source charge which is given by the unit coulombs, and epsilon naught is equal to 8.854 into 10 power minus 12 F farads per meter. So 1 by 4 pi epsilon naught is the constant. It can be otherwise known as K. It is noted as 9 into 10 power 9 Newton meter square per coulomb square. So of positive charge, it is noted that Q is greater than 0, that is the field is radially outward. For negative charge, q is less than 0, that is the field is radially inward. For vector form, E is equal to 1 by 4 pi epsilon naught into q divided by r square into r cap. As we said earlier, r cap is the unit vector. So let us have one problem based upon this. A point charge that is given q is equal to plus 2 microcoulombs is placed at the origin. Find the electric field intensity magnitude at the point 0.10 meter from the charge. The solution, the coverage, the charge is given as q is equal to 2 microcoulombs. While converting this to coulombs, it will be 2 into 10 power minus 6 coulombs. So the distance is noted as it is given as r is equal to 0.1 meter. Substituting these values in the formula, E is equal to k into q divided by r square. Computing the steps, k into q is equal to E into r square. So from this, r square is equal to k into q divided by E. So substituting all the values, it will be 1.8 into 10 power 6 Newton per coulomb. So answer E is noted as 1.8 into 10 power 6 Newton per coulombs. So this is another one example problem. So here E is given, E is asked. So here the charge is given. Substituting this values, k value and this charge value, E is equal to k into this q value and r. Substituting these values, it is noted as E is equal to 1.125 into 10.6 Newton per coulombs. Hope you all understand this session. Thank you for listening.